Welcome back, Geometry. We are doing more of the CST review, a little bit of these release questions. This group that we're going to be looking at is right triangles, part of my coughing there. Anyways, we have right triangles. There's a lot of stuff that we can do with right triangles, but probably the biggest ones that we do all the time, if I take this, let's go ahead and give ourselves a right triangle here. This one looks, it's close enough. There we go. Alright, biggest thing about a right triangle is that it has a 90-degree angle in one corner. And we always have this piece here that's opposite the hypotenuse, and we call these legs. And let's say, for example, we looked at this angle here. Sometimes we call that theta, or angle X, or even angle A, or whatever we want to call it. And if this is theta, then the leg over here, this would be considered the opposite leg. This one down on the bottom here, this would be the adjacent leg, and then the hypotenuse again is that diagonal piece across from the 90-degree angle. Biggest things that we can remember in dealing with right triangles is there's two main structures to work with. The first one is Pythagorean theorem, where we got leg squared plus the other leg squared equals the hypotenuse squared. Or we sometimes just say a squared plus b squared equals c squared. The other big one is the ratio relationships of SOHCAHTOA. These apply to all right triangles. Between those two theorems and approaches and problem solving techniques, that pretty much covers all of it. So let's go ahead and get started. The first one here, it says a diagram from a proof of the Pythagorean theorem is pictured below. Okay, so this diagram has been around, and as you look at it, what I'm thinking is I'm going to go ahead and label some parts on the diagram that might help me understand it a little bit better. I know that this is A and B, and it looks like if that's a square and all these sides are the same, then all these sides would be C on the inside. It also looks like this would be A, B, A, B, A, and B, just like that. And it's saying which one of these would not fit in the proof of the Pythagorean theorem. Well, let's say I'd even know the proof of the Pythagorean theorem. Let's just see if we can find one statement that does not look like it fits. Well, part A. It says the area of a triangle equals 1/2 AB. That looks pretty true because the area of a triangle is actually just 1/2 base times the height. And in this case, we have a base and height of A and B anyway, so that one does look true. What about part B? The four right triangles are congruent. Well, if they're all base and height AB, and they have this the 90-degree angle in here, they are congruent. In fact, if we want to cite a specific theorem, we have a side A is congruent to side A, then we have side B is congruent to side B, and we got an angle in between, so it'd be side angle side. We could even do like hypotenuse. Like there's a lot of different ways you could do it. So yeah, all these triangles are congruent around the outside. The area of the inner square is equal to half of the area of the larger square. I'm a little hesitant on that one. I don't think that it's true, but let's compare it with D and C, which one's maybe more true. The area of the larger square, so the whole square, that would look like, let's go ahead and make a square. So the area of the larger square is equal to the sum of the area of the smaller square. So if we take this same square and we have another one that's slightly smaller and also rotated, it's kind of like this. So it's saying that the area of the smaller square plus these four triangles on the outside make the area of the larger square. I think that's pretty true, because if I took that smaller square out, what would be left is those four triangles around the outside. So that one seems actually very true. But then C was kind of the hesitant one, so I'm going to go ahead and guess C. A right triangle's hypotenuse has length 5. If one leg has length 2, what is the length of the other leg? Well, that means we got a right triangle here with one side, another leg, and a hypotenuse. How do I know that one's the hypotenuse? It's always going to be opposite this right angle in the corner here, which is connecting the two legs. So it says one leg has length 2, The hypotenuse has length 5, and it's asking me, well, then what's the other side? Well, I know that leg squared plus leg squared equals the hypotenuse squared. That's the same thing as a squared plus b squared equals c squared, because c is that hypotenuse side. Okay, then that means that 5 squared could go here, and one of these legs could be the 2 squared, and I'm looking for that other leg squared. Well, 2 squared is 4, 5 squared is 25, and then we have this leg squared in between them, so I'm going to subtract 4 from both sides. Gives me a 0 on the left and 21 on the right. Leg squared equals 21. So if I square root each side of that, now we get the leg equals square root of 21. Hey, that's an answer. Awesome. Awesome possum. Let's do another one. What is the height of this rectangle? This almost seems the exact same. It's got a hypotenuse and a leg, and it's asking me to find the other leg. So even though it looks like it's asking a different question, it's the same thing. So I'm going to go ahead and pull this triangle out here. Shade that in a little bit. So we know this bottom 7 and this is 8. So we're going to have the same setup as before. Leg squared plus leg squared equals a hypotenuse squared. Well, leg squared, that means I got the 7 squared plus the other leg squared, which I don't know what that is, and then equals 8 squared. Well, 8 squared is 64, 7 squared is 49. And we got this leg squared. So if I subtract 49 from each side, it's going to make a 0 on the left. And I'll have leg squared equals, well, it's 64 minus 49. Same as 65 minus 50, so it's going to be 15. So the leg would just be the square root of 15. And that doesn't reduce or simplify or anything like that. So the answer would be C. These are pretty easy, as long as you just remember the templates you're working with. Pythagorean theorem and SOHCAHTOA. Okay, this is a slightly more advanced version of Pythagorean theorem. But let's see how that plays out here. I know that because I've seen this question before, but let's see how that actually comes out to play. A new pipeline is being constructed to reroute the oil flow around the exterior of the National Wildlife Preserve. The plan showing the old pipeline and the new route is here. So we got this old line here. The old line is this side of the triangle. And the new line is going to have 2 legs that make up that piece. So that triangle is the piece that we're looking at. So if I were to redraw that, it looks like about this. Here, here, here. And I know it's a right triangle. How do I know that? It's got this 90-degree angle in the corner. So I can do right triangle stuff with it. So that's 60 and 32. I would like to figure out what this third side is. Well, that third side is going to fit that Pythagorean theorem relationship. So leg squared plus leg squared equals hypotenuse squared. Okay, so the legs are 32 and 60, so 60 squared plus 32 squared equals a hypotenuse squared. Well, 60 squared would be 3,600. 32 squared, let's see, what's 32 times 32? 2 times 2 is 4, 2 times 3 is 6. Then we move over, 3 times 2 is 6, 3 times 3 is 9. I add this together, 4, 2, 1, 10, 24. So 3,600 plus 10, 24 equals hypotenuse squared. Now if I add those together, I would get 4, 6, 2, 4 equals the hypotenuse squared. So I got to figure out what the square root of this would be. And that's a tough one. Well, if I were to do 50 squared, let's try 50 squared and see how close that gets me. 50 times 50, that'd be 0. I can move over space, 5 times 0, and then we got 2,500. That's not quite there. Let's try 60. 60 times 60. 0 times 0 is 0. 0 times 6 is 0. 6 times 6 is 36. So we're getting closer. Let's try 70. 70 times 70. In fact, I shouldn't have even used these because I know that the hypotenuse is longer than 60. So I should have started with 70. 50 and 60 would have been nowhere even close. Well, this one I'm going to get that double zero again. 7 times 7 is 49. That's actually pretty close. So I'm going to say this side is about 70. For time's sake, we can't really be testing any more numbers. So let's go ahead and stick with that. Erase for some more space. So we know that this third side is about 70. So it says, how many extra miles will the oil flow once the new route is established? Well, I'm tempted to say 68, but that's not really what the question is asking. It's saying that this third side is going to be 70, but it says how many extra miles. They're pretty specific here when they use vocabulary like that. Extra means, you know, we have the old, and then we have the new, and the new is going to be the old plus some extra. So it's asking us, what is this extra? Well, we know the new is 70, and we know the old was, well, how much is the 70? That's 70 for the old is 70. Let's get this straight. So the old is 70, and the new is the 60 plus 32. That's going up and then around and down the other side. So 60 plus 32 is going to be 92. So, and that's actually pretty close right here, 92. Okay, so 92. So that's really 70, the old stuff, plus the extra. Well, how much would that be? If I subtract 70, that should tell me. 92 minus 70, that's going to give me about 22. The only answer that would be closest to that is 24. And if this third side was actually 68, then that would be exactly what we're looking at. Because remember, I guessed a little bit, and I actually overestimated. So that means that this third side should be about a little bit less than 70. So that should be close to 24. Next. The diagram shows triangle ABC. So I'm looking at this triangle, and it's asking which would prove it's a right triangle. How do we know something's a right triangle? Well, we know it's a right triangle if we got a right angle in it. Well, let's look at these things. Let's start from the bottom to the top. Distance from A to B equals negative distance from B to C. I'm automatically going to cross that out. Why? Because distance is not negative. It's kind of like a definition of distance. That has to do with the absolute value. Distance to 0, meaning not negative. Well, then let's look at part C. Distance from, A to B is the same as distance from B to C. Well, one might be tempted to say that. Let me go ahead and draw a triangle in here that's about the same size. Now this triangle is symmetrical on both sides, just like that one appears to be. And it looks like it would be a right angle, but what if it was kind of short like this? These two legs, or these two pieces here, the two shorter sides, are still congruent to each other. But this is not a right angle. So there's no way that equal distances make right angles. Because you can have right angles in equal distances, you can have not right angles in equal distances. So it's got to be one of these. Which one? Well, I know that perpendicular lines make a right angle, and I actually know which one of those it is. But using some reasoning and logic here, I notice that the first slope is positive and the second slope is negative. And it's saying one slope times the other. And if I have a positive times a negative, that would be -1. There's no way that it could be A. So I automatically know it's B, even if I didn't understand the idea of perpendicular slopes. By the way, a perpendicular slope is just the opposite reciprocal. That's a fancy way. Reciprocal. That's a fancy way of saying negative and flipped. You multiply it by a negative and you flip it. Easy. Alright, this one here. What's the distance of this line? I'm pretty sure is what they're going to be asking, but looks like my question went off the page a little bit. Let's bring it back. There we go. Oh, lower on the page. That's why it's happening. Well, this looks better anyways. What's the distance? Now, there is a distance formula, but let's say I didn't remember that. I know it's a bunch of junk in here where I got something squared plus something squared, and then I got like y minus y and x minus x or something like that. Anyways, this is from Pythagorean theorem, where we have leg squared plus leg squared equals the hypotenuse squared. This piece here would be the hypotenuse. We just got to figure out, are these two legs? Well, they actually give us those 2 points. They say that this goes from 0 to 8. So to move from 0 to 8, that's 8. Then to move from 1 to 7, that's going to be 6. Anytime you're trying to find out how far you moved, it's just the one number minus the other. And then think of distance as not negative. It's got to be positive. So we got 6 and 8. Now I'm going to give you a big hint. I know this is 10 because there's a special triple going on here. We have some triples, Pythagorean triples, where we can have 3 squared plus 4 squared equals 5 squared, 6 squared plus 8 squared equals 10 squared, 5 squared plus 12 squared equals 13 squared. Those are probably the 3 most common. There's plenty of others that are multiples of these, or there's a pattern that you can use to find them. And there's actually a couple other ones that are in there as well. But for this, it's going to fit one of these patterns. Let's say I didn't remember that though. I could still just plug it in and figure it out. I could have 6 squared plus 8 squared, leg squared plus leg squared, equals the hypotenuse squared. I'll just use the letter h. So that's 36 plus 64 equals h squared. 36 plus 64 is 100. So that means my hypotenuse is actually 10. B would have been the answer. In the figure below, sine of x equals 5 over 13. What are cosine of x and tangent of x? Well, if it's asking us about relationships with trig ratios, I always write this out, SOHCAHTOA. So we got SOHCAHTOA. So this tells me that sine is going to equal the opposite side over the hypotenuse side. If I look at these pieces, it says 5 would be my opposite and 13 would be my hypotenuse. So here's my opposite because it's opposite the x. The hypotenuse is opposite the right angle, so that's going to be 13. This side will be 5. Now just like I was saying earlier, there's those special triples, 3, 4, 5, 6, 8, 10, 5, 12, 13. That would help me figure this third side out here, being 12. But just to confirm it, if I were trying to figure it out, 5 squared plus the adjacent side squared equals 13 squared. 13 squared is 169, 5 squared is 25. Then we got the adjacent squared. If I subtract 25 from each side of these, you guys can probably already predict where this is going. The adjacent squared is going to be 144. And then that means that the adjacent, if I square root both sides, it's going to be 12. So I have 12, and it's asking me for cosine and tangent. Well, cosine, the relationship, is adjacent over hypotenuse with the h here, so ca. And then tangent of x is going to be the opposite over the adjacent. Well, the adjacent over the hypotenuse would be 12 over 13. And then the last one here would be 5 over 12. So all I got to do is find these pieces here confirmed in one of these answers. Looks like that's pretty easy. It's the first option. Cosine is 12 over 13 and tangent's 5 over 12. The other ones all have one little detail that's missed, like for example this one, the tangent's backwards. For C, the cosine is backwards. And then for D, this 13 shouldn't even be there, and the cosine is backwards. So A is our answer. Let's keep on moving, not wasting any time here. Make this a little bigger. In the figure below, sine of A equals 0.7. What is the length of AC? So it's asking us this length here. So we'll call this our hypotenuse, or H for short. And we know that if we have this angle here, because that's the angle that it's talking about, let's look at our trig relationships and see which acronym is going to help us. SOHCAHTOA. Okay, I got sine then. Okay, so sine of A is going to be opposite over hypotenuse. In this case, it's going to be 21 over h. So I have sine of A equals 21 over h. Well, the idea is to get h by itself and not in a denominator either. We want it in a numerator. So if we have this denominator here, I'm going to multiply both sides by h. Because h over h is now 1, and now it's on the other side in the numerator. Then I could also divide both sides by sine of A. Divide both sides by sine of A. That gives me a 1 on the left side. H equals 21 over sine of A. If I actually know what sine of A is, they gave that to me. So it's 21 over 0.7. So I'm really trying to divide 21 by 0.7. It's probably going to be a big number. But just a little tip to deal with decimals, you can always multiply a decimal by 10. And I can multiply a fraction by 1, which means the top and bottom is the same. If I were to multiply the top and bottom by 10 here, I'd get 210 divided by 7. The only reason I would do that is because sometimes we're a little uncomfortable with fractions and decimals in the same place. So it's easier to deal with them one at a time. 210 divided by 7, let's see how many times 7 goes into that. 7 and 21 is going to be 3 times in. That brings 21. Old long division has never failed us. Looks like it went in 30 times. The answer would be C. Awesome. Awesome, awesome, awesome. Ooh, this is a little bit off the page. Let's go ahead and pull it back. Alright, so they got all 3 relationships given to us here. We're probably only going to use one. So we got to figure out which one is the right one. Well, before I go any further, I know that I'm looking at SOHCAHTOA. So I'm going to go ahead and write out my acronyms so I know these relationships when they come up. They're asking me the height here. Now, this height of the street light, I'm actually going to call this opposite. So I'm going to put an opposite there. And how do I know it's opposite? Because it's across the triangle from the 40 degrees. Then I'm given an adjacent side. So which of my relationships has an opposite and adjacent? Well, I know it's for sure not sine because it's missing the adjacent. It's not cosine either because it's missing the opposite. It's the tangent. So tangent of the angle, in this case 40 degrees, equals the opposite over the adjacent, which is our h over 20. So tangent of 40 equals h over 20. Well, if I make a 1 here on the left by doing 20 over 20, then I can get that h by itself. That just means I got to multiply the other side by 20. So I have 20 tangent 40 equals the height. Not the hypotenuse, but the height. And they actually tell me what tangent of 40 is approximately. It's 0.84. So 20 times 0.84 is going to give me my answer. Let's figure that out. Well, I got 4 times 0, and then 4 times 2 is 8. 8 times 0 is going to be 0, and 8 times 2 is 16. So I got 1680. But I got to remember that this has 2 digits behind the decimal, so I'm going to move over twice, and it's 16.8. The answer would be C. The other distractors are probably from using the wrong relationships or doing your multiplication wrong. Right triangle ABC is pictured below. Which equation gives the correct value of BC? Ooh, this is interesting because they got not only the angle 32 degrees in here, we also have some of these 58s. You're probably wondering, where did they come up with that 58? I'm going to tell you the 58 is this angle up here, but how would I know that? Well, inside a triangle, there's always going to be an interior sum of the angles is 180. And if we know that this side's 90 and this side is 32, then we also know that this one has to add up to 180. That winds up being 58 then. So we got a lot more than just simple relationships here with one angle. It could be potentially the 32 or 58. We don't know which one. Well, let's just confirm them one at a time. It says sine of 32 equals BC over 8.2. Well, sine of 32 would equal the opposite over the hypotenuse. And the opposite is right. BC is opposite of 32 degrees. But 8.2 is not the hypotenuse. So that's wrong. When I'm looking at cosine of 32, that would be the adjacent over the hypotenuse. How do I remember these? From my acronyms. So, ka, to, wa. The adjacent's not BC, so B is wrong as well. Then we got tangent of 58. Now I got to change my orientation, my perspective, where I'm looking from. Because opposite's not BC anymore. Now it's 8.2. So 8.2, let's go ahead and change this here. This would be the opposite over the adjacent. And is 8.2 opposite of 58 degrees? It is. Is BC adjacent to 58 degrees? It is. Both the top and the bottom are correct. So C would be our correct relationship. Just to confirm, let's make sure that the last one's wrong. Sine of 58. Well, sine would have been opposite over hypotenuse. And BC is not opposite of 58 degrees. It's opposite 32 degrees, but not 58. And even though 10.6 is the correct hypotenuse, that BC part was incorrect. So the answer was C. We got another ladder question here. Lots of these ladders all over the place. 13-foot ladder is leaning against, let's see if we can see all the answers here, is leaning against a brick wall. The top of the ladder touches the wall 12 feet, so that's where this number comes from. And the ladder is 13 feet, and this is 5 feet. It says, what is the sine of the angle formed by the ground and the base of the ladder? So that must be down here, because I'm guessing the ground would be on the bottom. That would be kind of weird if you climbed a wall and this was the ground as well. Okay, so that's the ground, and it's asking about this angle right in there. Well, if I'm being asked about trig relationships, let's go back to our acronym, SOHCAHTOA. And it's asking about this angle down here. What is the sine of that angle? Well, sine is of the angle, whatever that is. We'll call it theta. Let's clean this up a little bit. Sine of theta is equal to opposite over hypotenuse. So we just got to figure out which piece is opposite, which piece is hypotenuse compared to this angle in the corner, the left corner, you could say. Well, the opposite would be 12, and the hypotenuse would be 13. So this should be 12 over 13. Let's see. Number 79. In the accompanying diagram, again, keep having these huge pictures, just a little bit too big for the whole thing. Measure of angle A equals 32 degrees, AC equals 10. Looks like it's almost covered up there. And which equation could be used to find x? So we got this bottom is 10 and this other side is x. And our angle is 32 degrees. So I'm going to go to my acronym, SOHCAHTOA. And I realize that I have the opposite piece and the adjacent piece. And if that's the case, then I'm probably going to be using tangent here, because I need both opposite and adjacent, and I don't need a hypotenuse. Sine and cosine are out. Well, tangent of 32, our angle, is going to equal the opposite over the adjacent, which is x over 10. And if I'm trying to get the x by itself, if it's trying to solve x by itself, I want to make a 1 with the 10. So 10 over 10 is 1. And I have 10 times tangent 32 equals x. Well, let's see if there's anything that matches that. The first one's using sine, so that's out. The second one's using cosine, that one's out. And the last one, D, that's using cosine, so that's out. It's got to be C. Now, if I didn't know how to solve this equation, I could actually have guessed C even earlier, because it's the only one that even uses tangent. The others are completely different relationships. Let's keep moving on. We're doing pretty good here. Good pace. Let's see if we can finish this in the next 10 minutes or so. The diagram shows an 8-foot ladder leaning against the wall. So this is 8 feet. And it makes 53 degrees here. Which is the closest distance up the wall the ladder reaches? So that's kind of hard thing to really understand in words, but the picture helps so much because they're telling us that this is our question mark that we have to figure out. Let's go ahead and call that X or H, whatever you want to call it, but I'm calling it X. Now, this triangle is not probably the more common orientation. In other words, the angle that it's focusing on is this top one instead of this one down the bottom. The one on the bottom is where we usually see that theta, that reference angle. So if that's our angle, that kind of changes the way we label our pieces. This diagonal piece is still the hypotenuse. But now this vertical piece is the adjacent side. It's not opposite. It's adjacent because it's right next to the angle. So if I go back to my acronyms, so ka, toa, I know that it's not sine because that uses opposite. Well, so does tangent. So it's got to be cosine because it doesn't use the opposite. It uses the adjacent and the hypotenuse. So looking at these pieces, that means that cosine of the angle, which is 53 degrees, is going to equal the adjacent side. In this case, x is the letter I chose, over 8 is the hypotenuse. This is my adjacent, this is my hypotenuse. Well, let's get that x by itself. See if we can get closer to figuring out its value. So I'm going to make a 1 with the 8 in the denominator. So multiply both sides by 8, and I get 8 cosine 53 degrees equals x. Well, thankfully, they've told me what cosine is approximately. It's 0.60, or just 0.6. So I'm going to do 8 times 0.60, which is 8 times 6, or 48. So this is going to be 4.8. There we go. The answer would be B. Number 81 here, triangle JKL is shown below. Which equation could be used, or should be used, it says, to find the length of JK? Alright, we got 24 degrees, and all of these here in the answer is 24 degrees. So we're going to stick to this angle. That's the only relationship we have. I like to use my acronym every time. SOHCAHTOA. Okay, so this is the angle 24. That means the JK side is going to be my opposite. And the LK leg is going to be my adjacent leg. And of course the 28 is the hypotenuse because it's across from the 90 degree angle. Well, if I'm going to use the 28 and JK is my opposite because this adjacent isn't really going to help me, which piece uses hypotenuse and opposite? Well, looking at my 3 choices here, it looks like sine is the relationship we have. Then that means sine of 24 degrees is going to equal something. I can automatically cross out cosine because those don't use JK. That would have been the LK side. And that means we need to have the opposite over the hypotenuse. Well, the opposite in this case is JK, and the hypotenuse is 28. Looks like our answer is A. B had the same pieces, but the relationship was backwards. They had hypotenuse over opposite. Alright, this one's a lot like what we did with the street lamp, except now we're looking at a tree, seeing how tall the tree is. It says, what is the approximate height in feet of the tree in the figure below? Well, I know that here's my angle, and I'm looking for the height, so that's my opposite side. And I also have my hypotenuse to help me form a relationship here. So if I'm thinking about SOHCAHTOA, the acronym, it kind of solves all these problems. Let's see which one we can use. We have the opposite and the hypotenuse, so we're going to use sine again. That seems to be pretty popular so far. So that means that sine of 50 degrees equals the opposite over the hypotenuse. And the hypotenuse in this case is 100. I'm going to multiply both sides by 100 to make that right side just a 100 over 100. So I have 100 times sine of 50 degrees equals the opposite. Now that's really the height. That's the height that I'm looking for of this tree. And that's the question that's really asking. Well, sine of 50 degrees is 0.766. So 100 times 0.766 is going to be 76.6. B would be our answer. Remember, you can pause the video at any time. Go and do it at your own pace, but I'm going to keep on going so I can make as many of these as possible. Alright, we have the same thing going on. It seems like this question never stops. SOHCAHTOA. Alright, I have an angle 35 degrees here, and the pieces I'm given are the opposite and the adjacent this time. The hypotenuse, not included. So that means cosine and sine are out. Both of those need the hypotenuse. Tangent, on the other hand, does not. So tangent of the degrees are 35 degrees equals the opposite, which in this case is x, and the adjacent is 6. So I've got to get that x by itself. I'll multiply both sides by 6. I have 6 tangent 35 equals x. 6 over 6 is really 1. And tangent of 35 is given to me in this little table here. Tangent of 35 equals 0.7. So this is going to be 6 times 0.7 equals x. In other words, that's 4.2. Or 42, and then I got to move the decimal. That's where I'm getting the 4.2 from. The answer would have been B. Oh, these are very similar. We can do these pretty fast now. If A equals 3 root 3, what is the value of B? Well, anytime that I see this kind of shape, it's a right triangle. I'm going to draw mine kind of upside down here. And let's go ahead and flip it. Let's rotate it around. Close enough. I think of this as a right triangle. Or not a right triangle, an equilateral triangle. If you look at that, I'm going to fade this out so you can see like how the pieces fill in. So that means we're going to split it right down the middle. And they're saying that A is 3 root 3. So this side right here is 3 root 3. That means that this other half would also be 3 root 3. And then each of these diagonal halves would be 6 root 3, or those two pieces added together. What it's asking me then is, what is this height? Well, there's a couple ways I can go about doing it. I can use Pythagorean theorem, or I can play on my memory of special right triangles. I'm going to use the old school Pythagorean theorem. Let's call this B. We know that 3 root 3 squared plus B squared, that's like A squared plus B squared, equals C squared, which is 6 times the square root of 3 squared. Well, to try and make this easier for myself, I'm going to rewrite this out, not just as 3 root 3 squared, but it's really 3 root 3 times 3 root 3 plus b squared equals 6 root 3 times 6 root 3. Remember, you can when you're multiplying a bunch of things in one chain, you can multiply them in any order. So this is really 3 times 3, which is 9, times the square root of 3 times square root of 3, which is 3, plus b squared equals 6 times 6 is 36, and square root of 3 times square root of 3 is 3. So if I subtract 27 from both sides, I can start to get this a little bit smaller. By the way, 36 times 3, that's 108, and 9 times 3 is 27. That's how I'm getting this 27. So I'll make a 0 there. I'll have b squared equals 108 minus 27. And let's see, what would that be? 108 minus 27, 8 minus 7 is 1, 10 minus 2 is 8. B squared equals 81. Wow, B equals 9. That was magically simple. Not really, it's mathematically simple. But anyways, if you wanted a shortcut way to learn that, we know this is a 30, 60, 90 triangle. It's a special relationship in which if we have the short side and we call that x, then the long leg is going to be x root 3 and the hypotenuse would be 2x. Notice that the difference between the short leg and the long leg is you multiply the long one by square root of 3. So whatever the short one is, I'm going to take that and multiply it by square root of 3. So if a equals 3 times the square root of 3, let's go ahead and write that out here, 3 times the square root of 3, then b is going to be a times the square root of 3, which is really 3 times the square root of 3 times another square root of 3, which is 9. So that is faster, but it requires that I memorize the formula. I'm just showing you guys it's doable both ways. Both work. What is the value of x in the triangle below? Ooh, this is interesting. Let's do it the shorter way though, because we got leg squared plus leg squared equals 10 squared, which is the hypotenuse. And I know that these two legs are the same thing, so that's x squared plus x squared equals 10 squared. Another way of saying that is 2x squared equals 100. And if I divide both sides by 2, trying to get this x squared by itself, that would give me 50. When I square root both sides, I'll have x equals, now square root of 50 is actually two square roots, one of them being 25 and 2. So the 25 simplifies. It'll be 5 times square root of 2. X equals 5 root 2. The answer would have been B. That was not hard at all. Last one of the night. What is the value of x in inches? Well, these are all in inches, so we don't really care about the units because we don't have any different units. Our answers are all going to be the same. So if we're looking at this, if we remember a second ago, we noticed that we had a special right triangle where the short side was x, and then the long leg was x times square root of 3, and then this hypotenuse was 2x. Let's replace that because we got an x already in the problem. Let's use something else. How about y, just for fun? We know that that does not look good. Let's draw a real triangle. We'll fix it. So look about like that other triangle. Close enough. All right. This side is y, and that means this side is going to be y root 3. It's going to be times the square root of 3 of whatever that original one was. And then the hypotenuse is double it, so that would have been 2y. Well, if y equals 7, 2y equals 14, and y root 3 is 7 square root of 3. So the answer would have been A. Too easy. And we're done for the night. Done. Check out the other videos. Keep on studying.